In this video, we're going to look at another example of testing hypotheses regarding two population proportions. So in this example, they did a study of binge drinking, and the percent who said they had engaged in unplanned sex because of drinking was 19.2% out of 12,708 people in 2013, and 21.3% out of 8,783 in the year 2021. Is this change statistically significant at the 0.05 significance level? So again, if I were approaching this problem and I didn't know what section I was in, like on the test when everything was going to be kind of jumbled up, the way that I would know that this was two population proportions is that when I look at this, number one, the type of data being collected is whether they engaged in unplanned sex or not. So that would be like a yes or no. This is qualitative data, which means we're dealing with proportions. And then beyond that, I'm seeing two different percentages for two different years and two different sample sizes. So that means I'm dealing with two different proportions. So first, let's check our assumptions. Okay. Over here. So our assumptions is number one, that we would have some sort of simple random sample here. It doesn't say that, but we will assume that it is a simple random sample. Number two, we check that n times p times 1 minus p, or n1 times p hat 1 times 1 minus p hat 1 is greater than or equal to 10, and then we'll do the same thing for our second sample. Okay, so let's write down everything we know. N1 is 12,708. P hat is 19.2%, so 0.192. So that's P hat 1. N2 is 8,783, and P hat 2 is 0.213. Okay, so when we plug those numbers into this equation, let's see what we get. 12,708 times 0.192 times 1 minus 0.192. Right, get my calculator. 12,708. All right, so I get 1,971.5. That's definitely bigger than 10, so we're good on that one. And then for the second one, we have 8,783 times 0.213 times 1 minus 0.213. And again, I'm going to put that in my calculator. And I get 1472.3. Again, bigger than 10. We are good on that one. Okay. We also want to make sure that both my samples are less than or equal to 0.05 times the population size. So in this example, our population said just in a study of binge drinking. So this is people who have been drinking. The people who have done this is a very large amount of people, and our sample sizes is 12,000, and then almost 9,000. That is definitely less than 5% of all the people who have binge drank before. So we can assume both of those are true. All right, so now let's set up our hypotheses. H naught. Since we're dealing with two population proportions, we will always set P1 equal to P2. Or in StatCrunch, this is the same thing as P1 minus P2 is equal to 0. And then H1, on this one, we want to see if the change is statistically significant. So it doesn't say, greater than, less than, any of that. So we're just going to say it has changed. And so we'll say P1 is not equal to P2, or P1 minus P2 is not equal to 0. Okay, and I want to point out on this slide over here, I'm about to do this in StatCrunch, but notice here in the top left, it says H naught is P sub 13 equals P sub 21. And H1 is P sub 13 is not equal to P sub 21. So instead of using 1 and 2, they are specifically referring to the year. So for 2013, they said, let's call that P13. And for the year 2021, they're calling that P21. So it's just an example of we can call our proportions something different based on the information given. I default to just saying P1, P2. All right, so let's walk through how to do this in StatCrunch. We do not have data, so we're going to go to Stat, Proportion Stats, to Sample with Summary, okay? And this is a little bit tricky here because I don't have the number of successes, right? It automatically gave me P hat. So we kind of have to work backwards here a little bit and say, well, P hat, all right, let's scroll over here. 0.192, that's equal to X divided by N. And we do know our N, well, I'll just say N1, right? 0.192 is equal to X over 12708. So if I want to solve for X, then I can multiply 12708 times the 0.192. So we're going to do that here. 0.192 times 12708. 192 times 12708. Okay, and I got 2,439.94. So I'm just going to put that in the number of successes over here. And number of observations with my sample size, 12708. Then we're going to do the same thing for our second p hat over here, which was 0.213. So I'm going to take 0.213 and I'm going to multiply it by that sample size, 8783. And that will give me my second X. I guess I should have named that other X, X1. And so let's do that. 0.213 times 8783. Okay, and so I got 1870.779. All right, so that's my number of successes, and then observations, 8783. We're doing a hypothesis test where it's either equal to 0 or not equal to 0, which it's already set as that, so I'm going to compute. And then here we get our z-stat. That's our test statistic, negative 3.78, and then p-value is 0.0002. That is a very low p-value. My alpha significance level is 0.05. So in this case, our p-value is less than alpha, which means we are going to reject H naught. Okay, so whenever we reject H naught, another thing that we could say is the results are statistically significant. And then there's another question here about whether this is practically significant. Okay, and we learned before about practical significance is like whenever we think about whether this matters, you know, for the research, we would have to look back and see, okay, well, what was the difference, right? So in the year 2013, the percentage of people who engaged in unplanned sex was 19.2%. And then in 2021, which was 8 years later, now the percentage has increased to 21.3%. So it would probably depend on whether, you know, the people doing this research considered that as important enough, right? Because that's only a difference of about 2%, which is an increase for sure, but like, is it a really drastic increase? Personally, I don't think it's super drastic, so I don't think it's really practically significant, but someone else might beg to differ on that one. So practically significant is more of a opinion-based thing. Okay, so in our next video, we will be looking at confidence intervals for two proportions.